Shown here are three linear measurement tools. The first one is a tape measure. Sometimes I call it a measuring tape. This one is a ruler. And at the bottom we have a steel rule. And I've written the names here. This is the steel rule. And this here is the ruler. And of course I have the measuring tape or tape measure. Let's look at the tape measure for a moment. This particular one is graduated in the imperial system or the inch system. And that means that all the large graduations between the 14 and the 15 is a distance of 1 inch. I'm not going to discuss how these things here are written and what they all mean, like this 16 right here is highlighted in red. What I'm more interested in is the end tab. This piece right here. You'll notice that the end tab floats. It's riveted into place and it floats. It goes back and forth. There we go. And that's such that the end tab resets the zero depending on how you're doing the measurement, because the tab itself has a bit of thickness. So when the tab is pushed in, the zero is here at this surface, and then you count 0, then 1/16, 2/16, 3/16. The discrimination on this particular tape right here, the graduations are 1/16 of an inch. And when the tab is out, okay, then the 0 is on the inside, starting on the inside part here, and then it goes 1/16, 2/16, etc. And the reason for that is because the thickness of the tab itself. Consider, you want to take a measurement using this angle iron. And if I choose to make a measure from the outside of this angle iron across to some other location, when I push on here, the tab itself, I pull on it, and immediately the tab then resets the 0 to the inside of this tab right here on the inside. Therefore, this part is 0. And when I make the measurement, it starts at 0, and 1/16, 2/16, etc., going down the measuring tape. If I wanted to make a measurement here on this surface, and I place the tab and the measurement tape, the tape measure against that surface and push in. When I push in, the tape measure moves inward, and it moves inward the thickness of that tab, pushing on inward. And now the 0 is now here. This now becomes the 0. And so I can make a measurement, 0, 1/16, 2/16, etc., going all the way down. So this is designed to go both ways. When I click on here, it extends outward, and when I want to measure on the inside, it moves inward, such that the 0 changes from that surface to the other surface. Let's do a quick measurement of that tab. I have here a vernier caliper. Let me turn this on. Now this will do fractions. I'm just going to change it over to imperial in fractions. There we go, it's in fractions. Let's do a quick measurement of the thickness of this tab. And I measured the tab to be 3/64 of an inch. What that means is the distance that the tab will travel then, as it readjusts to 0, that distance that it's going to travel going back and forth is 3/64 of 1 inch, such that the 0 changes from that surface to the inside surface, depending on how I am making the measurement. Now let's move on to the ruler and the rule. I'm going to place this measuring tape right here. I'm going to hook it up to the edge of my tabletop. Lock it down so it doesn't retract, and I'll just leave it here for us. And now let's look at the ruler and the rule. Now the ruler itself, this one here is also graduated in inches, just like the measuring tape is. And the discrimination of this ruler, as well as the discrimination of this measuring tape, is, well, it's the smallest value that I'm able to measure, which in this case is 1/16 of 1 inch. 1, 2, 3, 4, 8, 12, 16. So the discrimination, I'll write that here, of the measuring tape, and that one is 1/16 of an inch, and the discrimination of the ruler, and this is the ruler, is also in 1/16 of an inch. That's 1/16 of an inch for the tape as well as the ruler. And if we look at the rule, that's the steel rule. A good instrument will actually tell you what the discrimination is. And if you look at this, you will notice that the top, the scale, the discrimination is in tenths of an inch, and the bottom scale is in 50ths of an inch. And if I flip this over, it has metric on one side and metric on the other, imperial on the other, I should say. And the discrimination, or the smallest value to be able to measure using this scale, is 1 millimeter. And then this particular rule will also divide that into half a millimeter. So the biggest difference between the ruler and the rule is the precision. A ruler, well, this is a rough measurement instrument, rough measure. You'll be able to do a rough measurement to the nearest 1/16 of an inch, because that is the discrimination of this ruler. On the other hand, the rule, because it allows you to change or use a different scale with a higher discrimination, this is a precision measurement instrument. So the rule is more precision measurement. Another factor that we can look at is look at the lines here on the ruler. See how large they are, how thick they are, and compare that to the lines on the steel rule. Notice how much thinner the lines here are on the steel. That eliminates, well, it reduces the error in the readings, this thick line versus the very thin line. So this becomes more precision measurement instrument, whereas a ruler is, well, basically a rough measurement. The other thing about the rule and the ruler and the steel rule, on the rulers, okay, the zero starts here. There's a little bit of wood here, and the zero starts on the inside. That'll be the zero mark. And if you look over to the other side, this is graduated in millimeters also. So each one of these graduations here is 1 millimeter. And you'll note the zero starts here and has a little bit of wood here, so the zero is moved inward. Whereas on a steel rule, the zero is the actual edge itself. It isn't indented inward, as it is in a ruler. This is the zero right here, that very edge. Turning on both sides, that is the zero. And then you start from 1, 2, etc. So if I want to make a measurement using the steel rule, I simply butt it up against the item, and it starts at 0. Whereas I won't be able to do that with a ruler because I have that little gap. I have to move inward and basically take a guess as to where the 0 is. And there's another reason why I call this a ruler and this a rule. Now, if you look on the internet, I'm sure you will find various different definitions and comments, differences between a ruler and a rule. These are my interpretations, but there's one more, and that has to do with a thing called parallax. Parallax error. And what is parallax error? And let's have a look at a textbook. Here is a very good textbook for metrology. And let's have a look, see what it says about parallax error. Looking at this page, it says observational errors. And parallax is the top on the list for observational errors. And see what it says. Parallax is an important form of observational error in which an object appears to shift when the observer changes his or her position. Well, let's read that again. Parallax is an important form of observational error in which an object appears to shift when the observer changes his or her position. Well, it's easily said, but I think a demonstration is required to understand what it means here when an object shifts. So using our two, the ruler and the rule, let's have a look at parallax error. I drew a line here. Here it is. And it's just any length I just happen to draw on this page. And if I want to measure that line using the ruler, I line up the 0. Here's a 0. And I'm looking down, trying to line up that 0. And as I go across, I'm going to try and make a measurement. 1 inch, 2 inches. And each one of these graduations, as I said, is 1/16 of an inch. So 1, 2, 3, 4, 5, 6, 7, 8. And it's between 8 and 9/16 of an inch. Just a little over 2.5. And what parallax means, and because it's an observational error, the way I am reading this right now is I'm looking straight down. In looking straight down, the length that I see here is just a little over 2.5 inches. If I were to move my eye and I look at this angle from the right looking down, or if I would go the other way and look from the left, the object will move. The line that I have here is the object. And here's my measurement tool. This is the object, the line. Now let's have a look at what happens to the measurement tool, the scale, as I do the reading from the left, from the right, and from the left. I'm going to take my camera off my stand right now and go freehand in order to do this. So here we are looking straight down. And wait for the camera to come into focus somewhat. There we go. And you can see it's a little past 2.5 inches, the object. If I now go to my right, I'm going to move the camera to my right. Notice what happens to the object. The object is the line on the paper. The object is in fact moving. I'm going to wait for the focus to come back. Yeah, hopefully I haven't lost the focus altogether. There we go. So if I look directly down, okay, the actual measurement is a little over 2.5. If I go to my right, notice how the object is now moving. And so I can say that now, looking at from this angle, the length of that line suddenly becomes 2 and 4, 5/16 of an inch, just under 2 and 5/16 of an inch. Yet straight on, this is the proper way to do the measurement. It's just a little over 2.5 inches, or 2 and 4/16. And if I go to my left, you'll notice that the object now is moving to the left. And I seem to have lost the focus again. We'll bring it back. If I go to the left, notice how the object or the line on the paper is now moving, and it's less than 2.5 inches. That is known as parallax error. When making measurements, you need to look directly down. Now let's do the same thing. I'm just going to move this over using a steel rule. Forgive me as I try to manipulate this to about here. So I got the 0, and I'm interested in this end. If we look at this again, it's 2.5 inches. And the line, the object, is a little past 2.5 inches. And if I go to my right now, you'll notice that the object hasn't really moved that much. It's still just about where it was when I did from looking at it from this way. And if I go to my left, again, it doesn't look like it has moved much, the object. It has moved a little bit, not enough for us to really distinguish it here in this demonstration. And that would be using a steel rule. I'm going to go back now, put this back onto my stand, the camera that is. And let's see what the differences were between these two. This is the ruler, and here's the steel rule. And I said the ruler is a rough measurement, gives you a rough measurement, whereas the steel rule is more of a precision measurement instrument. The reason for this high parallax on the ruler is because has thickness to it. Right here, this piece of wood has large thickness to it. This particular rule also has a steel edge right here, and it's great for drawing lines. That steel edge is great for drawing lines. Not so great for making measurements, but fantastic for drawing lines. Notice how thick this is. So the measurement scale itself is up here on this plane, and the object is down there. And I have to travel through this thickness in order to make that measurement. That is what causes parallax. And on the other hand, if you look at the steel rule, it's thin. Notice how thin it is? So it is closer to the object. Because it's closer to the object, I don't have that height, parallax error is minimized. It's still a little bit here. Now, there still have some parallax errors it's still involved because it still has some thickness. There's still some thickness here. So there's still going to be some parallax error, which can occur, but it's much, much minimized. And when you're making measurement readings, in order to avoid parallax error, you need to read the instrument at 90 degrees to the object. So you're looking straight down. You're looking straight down, so you see the scale all the way down to the object, and then you make that measurement. Not from the side or this side, but straight down. Using a steel rule, okay, parallax is minimized, not eliminated, but minimized. Now let's look at the measuring tape. Does the measuring tape also have, or is it prone to parallax error? Well, the answer is yes. If you look to the measuring tape on the side, notice it is curved. That curvature, we really can't see it here. You notice there's a shadow under here. When I try to make this measurement or measure the length of this line, there is a large gap between the scale and the object itself, that large gap. So this is highly prone to parallax error because of the curvature that it has, which basically lifts this scale off of the paper or the item I'm trying to measure up a fair bit. So there's parallax error here because of this height, even though the instrument is thin, because I could minimize that by pushing down, and this becomes about the same thickness as my steel rule in order to minimize parallax. But typically these are read measuring tape using like this, so it's highly prone to parallax errors. And here now, in summary, we have a measuring tape or a tape measure, a ruler, which I call a rough measurement instrument, and a steel rule, which is more a precision measurement instrument.